Hello, this is Mr. Collier, and today we're going to be looking at some powers of powers. And what that means is we have an expression with some indices, and it's raised to another power. So let's look at some examples. I'm going to look at three forms. Let's just say we have a number to the power of m to the power of n. Okay, so that's just some number to the power of m to the power of m. So for example, let's say we have x to the power of 3 to the power of 2. Well, we can figure out the rule by writing this out as x cubed times x cubed. That's what x cubed squared means. X cubed times x cubed. And we already know from our rules for multiplication that we add together these exponents and we get x to the power of 6. So let's look at the exponents in our original question. We have 2 and 3, and we found that our resulting exponent was 6. So that's just 2 times 3. So what happens when you have an expression with an exponent raised to another power? You multiply the exponents together. Okay, so our rule, I'm going to write that rule down in red here. Our rule is, okay, any number to the power of a certain number, whether with an exponent, to the power of another exponent, you have to multiply the exponents together. So a to the power of mn is a to the power of m times n, or just, you can write that as just a to the power of mn. Okay, so that's a rule there. Another type of expression could be something like, you have more than one number. Like let's say we have a to the power of, or let's just say, yeah, okay, let's say we have a to the power of m and b to the power of, let's pick x or something like that. And then all that to the power of n. Okay, so let's take a look at an example. Let's say we've got x to the power of 2, y to the power of 3, all to the power of 3. Okay, so there's two things inside the brackets multiplied by each other. They both have indices. So what happens if we write that out, you actually get x squared y cubed, okay, times x squared y cubed times x squared y cubed. Okay, that's the definition. That's coming from this cube right here. We just expanded it like that. Alright, so what happens here is we have x squared, x squared, x squared. That becomes x to the power of 6. Y cubed, y cubed, y cubed. That's y to the power of 9. Okay, so notice that 3 times 3 is 9, and 3 times 2 is 6. So what happened is you just multiplied the 3 here by both of these exponents, and that's what we got. Okay, so for our rule here, we could say that a to the power of m, b to the power of x to the power of n equals a to the power of mn, b to the power of xn. Okay, that means just multiply the exponent by each of them, by each term that's being multiplied there. Okay, so let's look at another one. Let's look at some fractions. What if we had a out of b to the power of n? Alright, where b is not equal to 0 because you cannot divide by 0, so let me just stipulate that. So if we have something like that, and a specific example could be perhaps x out of y to the power of 3. Okay, if I write that out, that would be x out of y times x out of y times x out of y, because that's what cubing means. And here we have x times x times x is x cubed, y times y times y is y cubed. So notice here we had cubed and we had a fraction, so we cubed both of them, both the numerator and the denominator. Okay, that's where these 3's came from. Okay, so you can write a rule like that. A out of b to the power of n equals a to the power of n out of b to the power of n. Okay, so you exponentiate the numerator and the denominator. Alright, so let's take a look at some examples. Okay, in the first example, we've got a to the power of 3 raised to the power of 4. That means a cubed times a cubed times a cubed times a cubed. You just do 4 times 3, and you get a to the power of 12. Okay, in the second example, we have to be a little bit careful. This is negative y squared to the power of 4. So that means negative y squared times negative y squared times negative y squared times negative y squared. Your answer ends up being positive. Okay, if the exponent is an even number, you're going to end up getting positive. And one thing you can do to see this is you can break this down into negative 1 times y squared. You can write that negative as negative 1, and then it might be easier to see. This is negative 1 to the power of 4 times y squared to the power of 4. Okay, negative 1 to the power of 4 is going to be just positive 1. Okay, if that was an odd number, it would be negative 1. And here, y squared to the power of 4, you multiply the exponents, you get y to the power of 8. So that's just y to the power of 8. Here, to exponentiate this to the power of 2, you need to multiply both these exponents by 2. And you get x to the power of 6, y to the power of 4. A few more examples. Here we're going to be exponentiating everything to the power of 3, but here's a common mistake. Some people forget to exponentiate this negative 2 here. So it's going to be negative 2 to the power of 3, x squared to the power of 3, y cubed to the power of 3. Okay, negative 2 cubed is negative 2 times negative 2 times negative 2 is negative 8. X squared to the power of 3, and you have to multiply the exponents, so that's x to the power of 6, and this is y to the power of 9. Okay, when you exponentiate a fraction, each one gets exponentiated to the power of 4 here. So that's going to be p to the power of 4 out of q to the power of 4. And lastly, we have to exponentiate everything here in the brackets. So it's going to be negative 3 to the power of 2, x to the power of 2, and y squared to the power of 2. So you're going to have negative 3 squared, x squared, out of y squared squared. Okay, this gives you positive 9. We get x squared, and then the denominator, y squared squared. You multiply the exponents, you get y to the power of 4.